Most Alaskan volcanoes are in the Aleutian volcanic arc, which extends 2,500 kilometers along the southern edge of the Bering Sea and Alaska mainland. This classic volcanic arc contains some 80 quaternary stratovolcanoes and calderas, and 44 of the 54 historically active volcanoes of the United States. The Aleutian arc volcanism is the result of active subduction of the Pacific Plate beneath the North America Plate. In the past decade, hardly a year has passed without a reported volcanic eruption in the Aleutians. This is probably not because the arc has become more active, but rather because eruption detection has improved. There are about 80 named volcanoes in the Aleutian arc, of which 44 have erupted, several repeatedly, since 1741, when the written record begins in Alaska. This video provides views of some of the eruptions during the past 10 years. Volcanologists with the Alaska Volcano Observatory have gathered portions of this video from government and private sources. Boguslav Volcano is composed of a cluster of small, low-lying islands located 40 kilometers north of Umnak Island, behind the main axis of the Aleutian Arc, about 100 kilometers west of Dutch Harbor. The islands are remote and uninhabited, and are the emergent summit of a large submarine stratovolcano that rises more than 1,500 meters above the Bering Sea floor. The main island, Boguslav, has undergone dramatic changes in size and shape during historic time, an evolution which has been unusually well observed and recorded. The first historic eruptive activity was reported in 1796, and 8 periods of explosive eruptions, including episodes of lava extrusion, have occurred since. In 1988, when filmed by the United States Fish and Wildlife Service, the island consisted of 3 eroded remnants of previous eruptions. In early July 1992, passing airline pilots reported steam and ash plumes up to 8 kilometers above the main island. United States Coast Guard observations and photography in July confirmed that a new 100-meter-high lava dome had been constructed on the north tip of the island. Except for residual steaming of the dome, activity had subsided by late July. The hot material that emerged from the vent formed a lava dome that sloped down to the coast. This type of extrusion of lava has been responsible for the formation of many of the islands in the Aleutian Arc and elsewhere around the Pacific Ring of Fire. Although Boguslav Volcano erupts frequently, the activity poses no threat to high-flying aircraft. Westall Volcano is a broad, 1,560-meter-high, glacial-covered shield volcano on Unimak Island, 85 kilometers southwest of the tip of the Alaska Peninsula. The volcano is about 18 kilometers in diameter at the base and is built upon a large ancestral stratocone. Since the late 1700s, Westall has erupted at least 8 times, most recently in late 1991 and early 1992. On November 29, 1991, pilots reported the beginning of a fissure eruption through the ice, sending incandescent molten material several hundred meters into the air. The eruption fed a lava flow approximately 3 kilometers wide, as much as 10 meters thick, and about 7 kilometers long, extending down the northeast flank of the volcano. Debris flows reached the sea 17 kilometers from the vent. Dramatic fountaining and phreatic activity produced ash plumes that rose to an altitude of 7 kilometers, prompting the Federal Aviation Administration to divert air traffic. Most of the ash remained at low altitudes, and much of the fallout dissipated harmlessly over the Bering Sea or North Pacific. Light ash falls did occur on Unimak Island, including the village of False Pass, located 90 kilometers east of the vent. The activity subsided by mid-January 1992. Lava fountaining of this kind is similar to the eruption style of volcanoes in Hawaii, which are produced from very fluid lavas. These lavas come from magma generated within the ocean crust underlying the Aleutian Arc, unlike the volcanoes underlain by continental crust, whose magma is more viscous and can be highly explosive and dangerous. No monitoring instruments exist on Westall Volcano, and air traffic is commonly diverted away from the area whenever eruptive activity is reported. Veniamin Volcano is a large stratovolcano located 760 kilometers southwest of Anchorage on the Alaska Peninsula. The cone is 35 kilometers wide at the base, with a spectacular steep-walled, ice-filled summit caldera about 10 kilometers in diameter. The highest point on the caldera rim is 2,500 meters. An active intercaldera cone stands 330 meters above the ice field that fills the caldera. Geologic studies have shown that the caldera formed 3,700 years before the present. As with many of the remote volcanoes on the Alaska Peninsula and Aleutian Islands, reports of historic activity are often few and incomplete. The earliest known historical eruptive activity at Veniamin occurred in the 1830s. A total of 10 eruptive episodes were reported over the next 150 years. The most recent eruption began July 30th, 1993, and continued intermittently throughout 1993 and into 1994. During the eruption of 1983, presented here, lava flows from the summit crater of the intercaldera cone and adjacent subglacial volcanic activity melted 1/10 of a cubic kilometer of ice, forming a 1 by 2 kilometer, 120 meter deep, water-filled pit. The semicircular crevasses that surround the lake are indicative of substantial subglacial melting. The 1983 eruption was also filmed at night, capturing a spectacular fountain of lava pulsing from the summit vent. This volcanic activity is an example of Strombolian eruptive style, where hot, glowing material is ejected hundreds of meters above the summit, generating lava flows that can extend several kilometers from the vent. This hot material landed on the surrounding ice and snowfield, melting ice to produce water that filled the ice pit. Augustine Volcano, the summit of which is 1,260 meters above sea level, forms an island located 290 kilometers southwest of Anchorage in the lower Cook Inlet. Captain James Cook discovered and named Mount St. Augustine in 1778 as he sailed into Cook Inlet. The 8 by 11 kilometer island is composed of a central steep-sided cluster of domes surrounded by a pyroclastic debris apron. Seen in this false color satellite image, the irregular shoreline around the island is mainly the result of summit dome collapses that produced large debris avalanches that swept down the flanks and into the sea. Geologists have identified at least 11 debris avalanche deposits emplaced during the past 2,000 years. Hot pyroclastic deposits, represented in red, and cool debris flows, represented by dark blue, can be identified contrasting with the light blue representation of snow. Augustine is the most frequently active as well as the youngest of the Cook Inlet volcanoes. Since its discovery in 1778, Augustine has had 7 eruptions. The most violent historical eruption occurred in 1883, when a partial collapse of the summit resulted in a debris avalanche down the north flank that plummeted into Cook Inlet, extending the coastline by 2 kilometers. The avalanche generated a 10-meter-high tsunami, which traveled up to 100 kilometers away from the volcano, wreaking havoc on the coastline along the east side of the Cook Inlet. The most recent eruption of Augustine began in late March of 1986 and continued for 5 months, ending in August. The U.S. Geological Survey scientists responded to the eruption and documented the eruptive activity during fixed-wing observation flights. A nearly continuous ash-rich plume emanated from the volcano during the eruption. Pyroclastic flows cascaded down the flanks during the early stages of the eruption. During the later stages, lava extrusion began, culminating with the emplacement of a large summit lava dome and a short flow down the upper northwest flank. The lava dome is visible on the left side of the summit of the volcano. Innovative monitoring of ground deformation using techniques based on Global Positioning Satellite System is currently underway at Augustine to help detect long-term early warning signs to evaluate the possibility of an avalanche during the next eruption. Volcanic activity at Augustine Volcano ranges in style from explosive ash cloud-forming Plinian eruptions to dome building and sector collapse. Ash cloud interference with air traffic and possible tsunami are the most significant hazards from Augustine Volcano. One of the three active volcanoes along the western side of Cook Inlet, Redoubt Volcano, is located 170 kilometers southwest of Anchorage in the Aleutian Range. Prior to the 1989 eruption, the volcano was a largely snow and ice-covered stratocone that rose 3,100 meters above sea level. A summit crater, ice-filled during non-eruptive periods, was breached to the north by a deep gorge that dropped steeply down to the wide Drift River Valley, which extended 38 kilometers to Cook Inlet. The glacial ice which filled the crater and flowed down the gorge formed a broad lobe of ice across the bottom of the river valley. The historic eruptive activity at Redoubt has occurred within the summit crater, resulting in extensive melting of ice in the crater and gorge. Video of December 1989 shows the summit vent spewing ash. Individual eruptive events were difficult to document with video at Redoubt due to limited light conditions during the winter, poor weather conditions, and the response time due to the great distance between Anchorage and Redoubt Volcano. Typical eruptive style at Redoubt range from ash cloud-forming Plinian eruptions to dome emplacement and collapse, accompanied by pyroclastic flows. Fourteen lava domes were emplaced during the 1989 through 1990 eruption. The largest was estimated to be 30 million cubic meters of lava. During each eruption, the dome was destroyed to be replaced by a new one. The last dome formed in mid-1990 is still in place. This was the first eruption for the newly formed Alaska Volcano Observatory, whose scientists documented eruptive activity and the effects along the flanks of the volcano and the Drift River Valley. The proximity of the Drift River oil terminal located near the mouth of the Drift River and the potential for large volcanically generated floods increased the urgency for monitoring at the volcano. Spur Volcano, a quaternary stratocone, is located 130 kilometers west of Anchorage at the northeastern end of the Aleutian Range and is the easternmost and tallest historically active volcano in the Aleutian Arc. Spur Volcano is an ice-filled caldera about 6 kilometers in diameter, with Mount Spur, a resurgent cone or dome, forming the high point. The caldera is breached to the south, where landslide debris is overlain by pyroclastic deposits, and several glacial tongues extend down the flank towards the Chakachatna River. Crater Peak, a small composite cone 3.5 kilometers south of Spur's summit, is situated on the breach and has been the site of all the historic eruptive activity. Spur Volcano has been the most active Cook Inlet volcano during the past 10,000 years, producing at least 35 identifiable tephra layers. Two eruptions have occurred during historic times. In July 1953, a vigorous, short-lived eruption blanketed Anchorage with a half a centimeter of ash. The most recent eruptive cycle began in June 1992, and the three explosive eruptive events occurred over the next 3 months. During 1991 and 1992, Spur Volcano was the most intensively monitored volcano in Cook Inlet, and the Alaska Volcano Observatory seismologists closely followed the slow but steady seismic buildup prior to the first eruption on June 27, 1992. This event appeared to be similar to that which occurred in 1953, and a dramatic drop in the level of seismicity after the event seemed to indicate that the eruptive cycle was over. Almost 7 weeks later, on August 18, 1992, with virtually no precursory activity, Crater Peak roared back to life with another blast. This time, clear weather permitted an Alaska Volcano Observatory crew to arrive on the scene by plane shortly after onset of the eruption and capture the action on video. Westerly winds carried the ash cloud over Anchorage, where up to 5 millimeters of ash accumulated, disrupting commerce and closing Anchorage International Airport for 20 hours. A dark, ash-rich cloud roiled above Crater Peak to an altitude of about 18 kilometers. Spectacular shock waves were visible in the near-vent area near the base of the towering ash column. These waves were produced by rapid expansion of gas-charged materials through the restricted vent area of the volcano. The ash cloud rose above the white weather clouds in a vertical column, culminating in a wide, anvil-shaped head, which expanded mainly in the downwind direction. Approximately 55 million cubic meters of material was erupted from Crater Peak during this eruption. The material consisted of bombs up to 2 meters in diameter thrown 8 kilometers from the vent, to fine ash reported 1,200 kilometers away in Petersburg, Alaska.